Hello everyone. Today I want to explain the atoms and molecules. As we have done many topics, like we have uh, calculate the molecular mass, how we can make the formula that we have done. Okay, different types of elements and their formula. Okay, now I want to explain the remaining topic that you know that various elements combine to form one compound. Okay, so I have already told you that sugar, salt, sand, diamond, graphite, copper, these all are that minerals, these all are the means matter, you know. Okay, even the cloth that I wear, you wear, so that cloth is also matter. Everything which is present around us is a matter, or there will be the different kinds of matter, and in Hindi we will said that padarth, matter ko kya bolte hain, padarth. Okay, so an Indian philosopher, you know, that Maharishi Kanad said that if we go on dividing the matter, means we are dividing the matter, then we will get a smaller and smaller particle of matter. Ultimately we will get the smallest particle of matter which cannot be divided and further any further. Okay, so based on this philosophy, Kanad was one of the first person to propose that matter or padarth is made up of very small particles that are called parmanu. Okay, and John Dalton called these particles by the name atom. Okay, and the word atom means indivisible. Okay, something which cannot be divided further, so that is atom. Another Indian philosopher, Pakoda Katyayam, went to get a step further and proposed that particle of matter, atoms or parmanu, okay, normally exist in a combined form, and various combination of particles then get us various kinds of matter, and these combination form of you can say that atoms to know that called molecules. Got it? So when atoms are combined together, then they will form a molecule. So combined form of atom is known as molecule, or now called molecules. We know that all matter is made up of small particle, that is called atoms and molecules. So different kind of atoms and molecules have different properties, due to which different kinds of matter also show the different properties. Got it? So thus the property of matter depends on the property of atoms and molecules from which it is made of, and according to that I want to discuss the laws also. What are the laws? Okay, so let us discuss that laws. What are the different laws? Okay, so what are these different laws? Now you know that laws are there, two types of the laws are there: law of conservation of mass and law of constant proportion. So you can write that law of conservation of mass, law of conservation of mass. These laws are known as law of combination. Okay, so laws of combination, laws of chemical combination, these laws are known as law of chemical combination. Okay, laws of chemical combination. So first law of conservation of mass, and second law of constant or definite proportion. That law of constant proportion is also known as law of definite proportion. Okay, now let us define this law. that what is that law? Law of conservation of mass. What is that law of conservation of mass? I have already told you that if the uh, if the total mass of the product is equal to the total mass of the reactant, then it is said to be law of conservation of mass. Okay, so according to the law of conservation of mass, the mass of uh, means the mass of mass can neither be created nor destroyed. It remains constant during the chemical reaction. Means when the chemical reaction is taking place, the total mass of the reactant is equal to the total mass of the product. It will not change due to the reaction. So first is law of conservation of mass. Law of conservation of mass. According to this law, the mass can neither be created nor destroyed during the chemical reaction. Okay, or you can say that total mass of the product remains is equal to the total mass of the reactant during the chemical reaction. It means, for example, if we will take the calcium carbonate and we will heat that calcium carbonate, then we will get calcium oxide and carbon dioxide. If we will take that 100 gram of calcium carbonate, okay, then this mass 40 plus 16, it means we will get 56 gram of calcium oxide and 44 gram of carbon dioxide. So it means if we will plus them, we will get 100 gram. It shows that when calcium carbonate is decomposed into the calcium oxide and carbon dioxide, then 100 gram of calcium carbonate is decomposed and we get 56 gram of calcium oxide and 44 gram of carbon dioxide. So it shows that this is the reactant and this is the product. These are the products. So total mass of the reactant is equal to the total mass of the product. Okay. So according to the law of conservation of mass, that the mass of the mass can neither be destroyed nor created or nor created neither destroyed, so that during the chemical reaction or the total mass of the reactant is equal to the total mass of the product. It means during the chemical reaction it will not change. Okay. Second law is law of constant proportion. Okay, so what is the law of constant proportion? Actually, the law of constant proportion was given by Proust in 1779. Okay, Joseph Proust, and he analyzed a chemical composition, that type of elements present and percentage of elements present. Okay, so that he has taken the composition of a large number of compounds and came to conclusion that the proportion of each element in the compound in the is constant, or you can say that is fixed. Okay, based on these observations, Proust formulated the law of constant proportions. According to the law of constant proportions, a chemical compound always consists of the same elements combined together in the same proportion by mass. This law means that whatever be the source from which it is obtained, or maybe that means that whatever the source will be there, that may be you can say that compound is every time is made up of by the elements, and it may be made by the same elements in the same mass by percentage. For example, water is a compound. Okay, and that water contains that, what is the formula of water? H2O. Okay, so that water contains the 2 ratio 16, it means 1 ratio 8. So water is formed by the this fixed ratio only, 1 ratio of hydrogen and 8 ratio of oxygen. So ratio remains same. When the water is formed, means the compound water is formed, then its ratio is fixed, that is 1 ratio 8. Okay. So let us write the definition of this law. Let us write it. You can write the definition. So first you can write the law of constant proportions, or law of definite proportion. It is also known as law of definite proportion. Okay. So according to the law of constant proportions, you can write according to the law of constant proportions, according to the law of constant proportions, okay, then a chemical compound always, a chemical compound always, a chemical compound always consists of the same, consist of the same element, consist of the same elements combined together, combines together in the same ratio, in the same proportion by mass, in the same proportion by mass. Okay. So that is the main thing. For example, water, H2O. Its proportion by mass is 1 ratio 8. Every time its proportion is 1 ratio 8. Whenever the water is formed, then its proportion is 1 ratio 8. So this is the fixed proportion for making the compound water. We can take the another example. For example, ammonia. It contains NH3. So N has 14 ratio 3. So for that ammonia is formed by the 14 ratio 14 mass, 14 gram of mass of nitrogen and 3 gram of mass of hydrogen. So that ratio is fixed, it will be not change. Okay. So you can say that we can take that this another example of ammonia to illustrate this law. Okay. According to that that ammonia is a compound, and it has been found by the analysis of that ammonia always consists of the same two elements. These elements are always nitrogen and hydrogen. Okay. And these are combined together in the same ratio of 14:3 by mass. Got it? So this mass will never be changed, it remains as it is. You know that this law is given by Joseph Prost. Okay, so that is complete, this law completed. Now you can do the questions also, that is based on the laws of chemical constant proportion and law of chemical combination. Okay, now let us do the another topic. Atom is the smallest particle of an element. Element that can take part in chemical reaction. Before I want to discuss the Dalton's theory, Dalton's atomic theory, I want to discuss the atom. As I told you that Dalton was born in 1766 in poor weaver's family in England. He received his early education from his father at the village school. Okay, and Dalton started teaching in the village at the age of 12. In 1793, Dalton left for Chester to teach the physics, chemistry, and mathematics in a college. Okay. In 1794, he described color blindness, and in 1808, Dalton presented his atomic theory to explain the properties of matter. Dalton's atomic theory of matter became one of the foundation of modern chemistry. Dalton was the first to calculate the masses of the atoms of several elements, and he died in 1844. Okay, so as I told you, there's just all the houses are made up of bricks, and in same way all the matter is made up of atoms, and thus atoms are the building blocks of all the matter around us. In chemistry, atom is defined as you can say that atom is the smallest particle of an element that can take part in a chemical reaction. So, we can define the atom, that an atom is the smallest particle of an element that can take part in chemical reaction. Okay, and you know that atom is very small in size, and the size of an atom is indicated by its radius, which is called atomic radius. So, atomic radius is measured in nanometers. Got it? So, the size of atom or atomic radius is measured, atomic radius of an atom is measured in nanometers. So, nanometer is the SI unit for the atom. You can say atom is very small, so that nanometer is also very small unit for measuring the length of the radius. Got it? So, the symbol of nanometer is small n m, small m. So, you can write that atomic radius is measured in nanometers. Nanometers means small n and small m, that is nanometer. So, you know that 1 nanometer equals to 10 to the power minus 9, or you can write that 1 upon 10 to the power 9 meter, or you can write it like that also, 1 equals to 1 nanometer equals to 10 to the power minus 9 meter. Okay, so that we can write that also. Okay, so hydrogen atom is the smallest atoms of all. You know which is the smallest atom? Hydrogen atom. So you can write that also. Hydrogen atom is the smallest atom. Hydrogen atom is the smallest atom. Okay, so which is the smallest atom? Hydrogen atom is the smallest atom of all, and the atomic radius of hydrogen is 0.0037 nanometer. Okay, 0.0037 nanometer. This is the radius of hydrogen. Okay, so it is very small in size, and it is really very small, you know that. So the atomic radius of the some elements are given in your book also. You can take the idea from those elements or those radius. So atoms are so small we cannot see them even under the powerful microscope or powerful optical microscope. We are not able to see them. So these actually we are using the this thing STM. Nowadays the STM is used for it. So STM is mainly scanning tunneling microscope. Scanning tunneling microscope. STM is scanning, you can write scanning tunneling microscope. Scanning tunneling microscope. Okay. So scanning tunneling microscope will uses now actually it will produces the magnified images, the more advanced type of electron microscope, that is STM, scanning tunneling microscope. Okay, and this microscope produces the computer generated images or pictures of the surface of the element, and it show the individual atoms. Okay, so the atoms show up as blurred spheres, but the scanning tunneling microscope enables us to see the atoms through though indirectly. Okay, so we can just use the STM, scanning tunneling microscope, to see the atoms. Okay. Now let us do the another topic, that is Dalton's atomic theory. So let me rub the portion first. Now let me start the Dalton's atomic theory. Okay, Dalton's atomic theory. Dalton's atomic theory. Okay. So what is Dalton's atomic theory? You have heard about that also. The theory that all matter is made up of very tiny individual particles, that are atoms, is called atomic theory of matter. Dalton's put forward his atomic theory of matter in 1808. So, the various postulates of Dalton's atomic theory of matter that we will discuss later on. First of all, write the Dalton's atomic theory or atomic theory of matter. What is that? The theory that that you can write here. Actually, Dalton's atomic theory, that theory of matter which has put forward by the Dalton, that is known as Dalton's atomic theory. Okay, now you can write the theory that the theory that all matter all matter of all matter of all matter is made up of all matter is made up of very tiny indivisible particles. So you can write all matter is made up of very tiny indivisible particles. What is the name of these particles? Atoms. Okay, these particles are known as atoms. and that is called atomic theory of matter. So is called atomic theory of matter, is called atomic theory of matter. And you know that Dalton put forward his atomic theory of matter in 1808. So he has given the various postulates. So what are these postulates? First postulate is that all the matter is made up of very tiny particles called atoms. So you can write the postulates of Dalton's atomic theory. What are these postulates? Write these postulates. First postulate is, you can write that all the matter is made up of, all the matter is made up of very tiny particles or very small particles, very small particles called atoms, This is the first postulate. Okay, so that all the matter is made up of very tiny particles or very small particles, that is called atom. Second postulate is that atoms cannot be divided. You can write that atoms cannot be divided. It means they are indivisible. They cannot divide further. Okay, and third one, atoms can neither be created and nor destroyed. So you can write atoms can neither be created nor destroyed. Atoms can neither be created nor destroyed. Okay. After that, you can write the next postulate. That postulate is atoms are of various kinds, and there are as many kinds of atoms are as are elements. Okay, so these various kind of atoms are found in the form of elements. Got it? So you can write that also. Postulates we are doing. So write these postulates. Okay. So next postulate you can write that. We can write here also fourth postulate. Okay. Fourth postulate, write atoms are of various kinds. Atoms are of various kinds. For example, iron, then copper, then magnesium, potassium. So magnesium is formed by the magnesium atoms, potassium formed by potassium atoms, iron formed by the iron atoms, copper formed by copper atoms. So various types of atoms are there, and there are many kinds of the atoms of elements are also there. Now next is all the atoms of a given element are identical. All the atoms of a given element are identical. Identical means same. For example, the atoms which are present in copper, they are identical. Means the copper atoms are present in the copper element. So all the atoms of a given element are identical or in every respect. You can write identical in every respect. Every respect. Okay. So, if I want to say that having every respect means having same mass, having same size and having same chemical properties. So, these are the respects, every respect in which they are identical. Now, atoms of different elements, different mass, different size and different chemical properties. So, you can write that atoms of different elements have different they have different properties also, chemical properties and physical properties, both are different. So you can write that all the atoms of a given element, they are identical. Now you can write the next one, that atoms of different elements, it will opposite to this one, atoms of different elements, atoms of different elements are differ in mass, differ in mass, ठीक है, mass differ होगा. For example, the mass of iron is differ from the mass of copper because the elements are differ. So differ in mass है, then size and chemical properties, differ in mass, size and chemical properties. You can say that कि atoms of different elements have differ in physical as well as chemical properties. But if atoms are all the atoms of the same element, then it has physical and chemical properties are same. Got it? Now next we can write that next postulate. Next postulate we can write chemical combination you know that chemical combination between two elements consist, so chemical combination between two elements consist in the joining, two elements consist in the joining. What it will be consisted when the two elements are combined together, then it will form the compound. Okay, and the molecules of compound will be formed by it. So chemical combination between two elements or more than two elements consisting in the joining together to the atoms, joining together to the atoms of these elements to form atoms of these elements to form what it will form? It will form molecules of compound, to form molecules of compounds, molecules of compounds. Okay. Next postulate, we can write the next postulate, that the number and the kind, you can write the next postulate, the number and the kind, the number and the kind of atoms, kind of atoms. Actually, the number and kind of atoms in a given compound is fixed. Okay, so the number and the kind of atoms in a given compound, you can write in a given compound is fixed. In a given compound is fixed. Okay, and next is that during the chemical combination, during the chemical combination, atoms of different elements combine, atoms of different elements combine, different elements combine in small whole numbers, okay, in small whole numbers to form compounds, okay. And last, you can write that also, last postulate, you can write the last one, that is atoms of the same elements can combine. So atoms of the same elements can combine in small can combine in more than one ratio, more than one ratio to form more than one compound, okay. So these are the postulates, Dalton's postulates. So learn them, and according to that, these postulates will be based on the chemical combination also. So so please do that. With this, thank you and have a nice day.